So I wanted to highlight one of these problem-solving strategies, the Polya method, which is, if you've also heard of the four-step method, this is something that's very similar to that. It was written down by Hungarian mathematician George Polya. He identified 4 basic principles for how to solve a problem. 1, understanding the problem. That's the first step. 2nd, devise a plan to solve the problem. 3rd, carry out the plan. And 4th, look back. Reflect and see if your answer makes sense. See if you've solved the problem. So I'll show you an example of how we demonstrate the Polya method to the students in one of our solutions. And so I'll discuss the details of each of the steps, giving an example of one of our problems from 4th grade, I believe. And I'll show you how we go about presenting the solution to the student and how they're divided in the solution. So here, first of all, this is the entire solution. This is all 4 steps that are combined into one. Next, I wanted to show you how they're divided, how the 4 steps are divided in the solution. So first of all, you'll see that there's a whole lot of real estate taken up by step 1, by understanding the problem. 2, 3, and 4 have less space dedicated to them. And I'll talk to you a little bit about why we do that. All right, so let's walk through the steps one by one. Step 1, understanding the problem. As I said before, this is the majority of this particular solution. And it's something that at first glance might seem simple, but it's something that students often struggle with, especially with difficult problems, because they don't understand what the problem's asking them. They might not fully read through the problem. They might not understand what they're being asked to do in a rush to start calculating. And understanding the problem is the first step to solving any problem. So we devote a lot of time to this. In this particular problem, it may seem easy. All right, so we see 7, we see 2 times, let's just multiply. And that may be a strategy for solving some simple problems, but as the problems get more and more complicated, it's going to cause problems for the students. The next step, step 2, devising a plan. There are often a lot of different ways to solve one particular problem, and many programs just show the student how to solve a problem, but we want to help the students devise the plan themselves, and we want to gently guide the student if they're having trouble. So here in this particular part of the solution, you'll see it's written down already because I've answered it, but actually we ask the student to make the expression themselves. We give them different numbers, different operators, and the student should develop the plan themselves. If they're not able to, then in a second layer, we'll provide some additional scaffolding to help the student understand what's going on here and give them a second try in making that. Step 3 is to carry out the plan. So now that we've devised the plan, the student needs to carry it out carefully and patiently. We provide scaffolding and support on this, so if the student can't carry out the plan, they make some mistake with the mathematical calculations, we'll be able to, and we'll provide additional support for the student to help them see where they made their mistake. So here, step 3, this is often the only part of a solution that's given for word problems or for problems. So just teaching step 3 alone is fine for teaching students basic math skills and teaching algorithms, but it can't teach those higher level problem solving skills. Step 3 might have been enough in previous generations of exams, but with next generation assessments, it's not enough. And finally, step 4, looking back. At the end of every single problem, we summarize what we've seen, what we've figured out, and present that to the student in a way so that they can reflect on it, they can look back on what's been done, they can look back on the answer, and understand what we've achieved.